The morning of July 18, 1944. A Sherman tank of the 2nd Armoured Division idles at the base of a hedgerow near Saint-Lô, France. Its commander, a lieutenant from Ohio who 6 weeks earlier had waded through surf thick with blood at Omaha Beach, stares at an obstacle more formidable than any Atlantic wall fortification he'd trained to overcome. It's a wall of earth, roots, and centuries-old vegetation rising 12 feet high, crowned with brambles thick enough to stop a man. His tank designed to punch through German lines, to exploit the breakthrough that months of planning promised would follow. The D-Day landing sits impotent before a fence line that French farmers have cultivated since the Middle Ages. This is the bocage. And in the 6 weeks since the beaches, it has transformed victory into a grinding stalemate that no one had anticipated. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The problem was elegant in its simplicity and devastating in its implications. Normandy's interior, the ground that separated the Allied beachhead from the operational freedom of the French countryside, was a medieval landscape of small fields divided by ancient earthen embankments. Each field, and there were tens of thousands, was bordered by hedgerows. Dense walls of earth, sometimes 4 feet thick at the base, rising 8 to 12 feet high, topped with centuries of accumulated root systems from oak, elm, and hawthorn trees grown so thick together their branches formed an impenetrable canopy. These weren't the decorative hedges of an English garden. These were fortifications created by 1,000 years of agricultural practice, where each generation of Norman farmers had cleared stones from their fields and piled them at the boundaries, where wind-blown soil had accumulated, where vegetation had taken root and grown into barriers that could stop a tank as effectively as any concrete wall the Wehrmacht might construct. The Allied planners, studying aerial photographs and maps in England during the months before D-Day, had noted the field patterns. They'd seen the characteristic bocage layout, the small irregular fields, the dense hedgerow networks. But aerial photography, even the best available in 1944, couldn't reveal what those lines on the map meant on the ground. The photographs showed boundaries. They didn't show that those boundaries were 12-foot walls of earth and root, spaced every 100 to 200 yards, turning the entire Norman interior into a maze of natural fortifications. The German defenders understood what the Allies had overlooked. When Field Marshal Erwin Rommel toured Normandy in the spring of 1944, preparing defences against the invasion everyone knew was coming, he'd recognized the bocage for what it was, the perfect defensive terrain. Every hedgerow was a ready-made firing position. Every field was a kill zone. Every sunken lane between the embankments was a natural trench system that required no digging. The Wehrmacht's tactical doctrine adapted instantly. Instead of fighting the terrain, they embraced it. They positioned machine gun nests at hedgerow corners where they could enfilade entire fields. They registered mortar coordinates on the narrow gaps where roads cut through embankments. They positioned anti-tank guns in the hedgerows themselves, camouflaged by vegetation, with clear fields of fire across the small Norman meadows. They transformed an agricultural landscape into a defensive system that would have taken months and tremendous resources to construct artificially. For the American infantrymen advancing from the beaches in June of 1944, the bocage became a nightmare of incremental warfare. Each field was a separate battle. You crossed a hedgerow, cleared a field, reached the next hedgerow, and the process began again. Visibility was measured in yards. Artillery spotting became nearly impossible. The overwhelming Allied air superiority that had dominated the skies above the landing beaches meant little when you couldn't see the enemy position 30 yards away, hidden in vegetation thicker than any smokescreen. But it was the American armor that faced the most humiliating tactical defeat. The Sherman tank, which had performed admirably in North Africa and Italy, which had been designed for the war of movement that everyone anticipated would follow the breakout from the beaches, became a liability in the bocage. The problem wasn't the Sherman's armor or its gun, though both would prove inadequate against German heavy tanks in different ways. The problem was more fundamental. The Sherman couldn't get through the hedgerows. The standard approach, The tactic that seemed obvious when facing an earthen wall was to drive the tank straight at the embankment and push through. The Sherman weighed 30 tons. Its engine produced 400 horsepower. It should have been able to bulldoze through vegetation and dirt, and for the first few feet, it did. The tank would climb the earthen embankment, its tracks churning for purchase in the soil, its nose angling upward as it mounted the obstacle. Then physics intervened. As the Sherman climbed the embankment, its center of gravity shifted. The nose rose higher. The tank's underbelly, its thinnest armor, designed never to be exposed to enemy fire, became visible. And in that moment of vulnerability, with the Sherman's tracks spinning uselessly in air, unable to find purchase, with its belly armor exposed to any German soldier with a Panzerfaust rocket launcher crouching in the next field, the tank became a perfect target. German defenders learned to wait for this moment. They'd let the Sherman commit to climbing the hedgerow. They'd watch the tank's belly armor come into view, and then they'd fire. The Panzerfaust, a crude but effective shaped charge weapon that could be operated by a single infantryman, could penetrate the Sherman's thin underbelly armor with ease. Crews burned. Tanks that had survived the Atlantic crossing, survived Omaha Beach, survived the initial push inland, were destroyed trying to cross fence lines. Tank commanders adapted by refusing to attempt the direct assault. Instead, they searched for gaps, places where roads cut through the hedgerows, where gates provided openings between fields. But the Germans knew where these gaps were. They'd registered them with mortars and anti-tank guns. The gaps became kill zones more dangerous than attempting to climb the embankments. Some crews tried a different approach, using the tank's cannon to blast holes in the hedgerows. This worked, technically. The 75mm gun could certainly destroy vegetation and earth. But it took multiple rounds to create an opening large enough for a tank to pass through. Each shot announced the tank's position to every German defender within hearing distance. And ammunition was finite. A Sherman carried 90 rounds for its main gun. Spending a dozen rounds to create a passage through a single hedgerow was unsustainable when there were hundreds of hedgerows between your current position and any meaningful objective. Engineers attempted to use explosives. Bangalore torpedoes, designed to clear barbed wire and minefields, were repurposed to blow gaps in hedgerows. This worked better than tank fire, but it required infantry to approach the hedgerow, emplace the charges, and detonate them while under fire from the next field. The casualties mounted. The progress remained measured in single fields per day. By late June, barely 3 weeks after the triumphant landings, the American advance had ground to a crawl that recalled the worst stalemates of the First World War. Units that had been trained for mobile warfare, that had prepared for the rapid exploitation that armored doctrine promised, found themselves fighting for individual fields in a landscape that seemed designed to negate every advantage they possessed. The First Army's advance towards St. Lo, which should have been achieved within days of the landing, was measured in yards per day. Casualties mounted at rates that rivaled the worst battles in Italy. Entire companies were ground down, taking objective lines that on a map appeared to be barely a mile from their starting positions. The hedgerows consumed units like a machine, replacing the war of movement that Allied doctrine anticipated with a medieval siege conducted field by field, hedgerow by hedgerow. Officers began to speak privately of the possibility that the Normandy campaign might stall entirely, that the Allies might find themselves confined to an expanded beachhead, but unable to achieve the breakout that the entire invasion strategy depended upon. The overwhelming superiority in men, material, and industrial capacity that America brought to the European theatre meant little when the terrain itself prevented the deployment of that superiority. And then, in early July, in a tank depot behind the lines near Omaha Beach, a sergeant from the 2nd Armored Division began welding pieces of German beach obstacles to the front of a Sherman tank. His name was Curtis G. Cullen, Jr. He was a cab driver from Chicago before the war, drafted into the Army, trained as a tanker, promoted to sergeant based on competence rather than any particular genius for innovation. He hadn't attended engineering school. He had no background in metallurgy or design. What he had was 6 weeks of experience watching tanks fail to penetrate hedgerows and access to a beach covered in steel obstacles that the Germans had emplaced to stop landing craft, but which now, after the successful invasion, served no purpose except as scrap metal. The obstacles Cullen selected were Czech hedgehogs, welded steel beams arranged in X patterns, each weighing several hundred pounds, designed to rip the bottoms out of landing craft at high tide. Thousands of them littered the beaches. They'd been bypassed during the invasion, rendered irrelevant the moment Allied troops moved inland, but their steel was high quality, and their angular structure gave Cullen an idea. What if, instead of trying to push through a hedgerow or climb over it, a tank could cut through it? What if you could mount blades on the front of a Sherman that would act like tusks, penetrating the earthen embankment at ground level, and using the tank's forward momentum to slice through the root system that gave the hedgerows their strength? The concept wasn't entirely original. Other tankers had experimented with various cutting devices. Some units had welded pipes to the front of their tanks, others had tried mounting saw blades. But these improvised modifications either lacked the strength to penetrate the dense root systems or created new problems, adding weight that slowed the already underpowered Sherman, or extending so far forward that they made the tank unwieldy in the narrow lanes between hedgerows. Cullen's innovation was in the specific geometry of his design. He cut sections of the Czech hedgehogs into prongs roughly 4 feet long. He welded these prongs to a steel plate that could be mounted on the front of a Sherman's hull, angled slightly downward. The prongs he used 4 in his initial design, though this would vary in later iterations, were spaced to penetrate the hedgerow at ground level, where the earthen embankment met the soil of the field. The angle was critical. Too horizontal, and the prongs would push the hedgerow rather than penetrate it. Too vertical, and they'd act like a ramp, lifting the tank's nose and recreating the vulnerability problem that made standard hedgerow assaults so deadly. Cullen's angle allowed the prongs to bite into the earth and roots while keeping the tank's center of gravity low and its belly armor protected. He built the first prototype in early July, working in his unit's maintenance area, with the unofficial blessing of officers who were desperate for any solution to the hedgerow problem. The welding was crude but functional. The device added perhaps 500 pounds to the Sherman's weight, significant but not crippling. When mounted, the prongs extended about 4 feet beyond the tank's glacis plate, far enough to penetrate a hedgerow before the tank's hull made contact, but not so far as to make the tank impossible to maneuver. The first test was conducted on a hedgerow behind the lines, away from German observers, but on terrain identical to what the divisions faced at the front. Cullen's tank, now sporting what looked like steel tusks, approached a typical Norman hedgerow at moderate speed. The prongs struck the embankment at ground level. The tank's engine roared as the driver maintained speed, and the Sherman punched through, not over, not around. Through. The prongs cut through the root system like blades through flesh. The earthen embankment, its structural integrity compromised by the severed roots, collapsed or was pushed aside. The tank emerged into the next field in seconds, its belly armor never exposed, its crew never vulnerable to the Panzerfaust ambush that had destroyed so many Shermans attempting conventional hedgerow assaults. Word of Cullen's device spread through the 2nd Armoured Division with the speed of salvation. Within days, other crews were fabricating their own versions. Engineers studied Cullen's design and began producing more refined iterations. The basic concept remained steel prongs mounted low on the Sherman's glacis, angled to cut rather than push, but variations emerged. Some crews preferred 6 prongs instead of 4. Others adjusted the angle or the length based on the specific hedgerow terrain in their sector. The breakthrough came when 1st Army Headquarters learned of the innovation and recognized its potential to transform the entire Normandy campaign. This wasn't just a clever improvisation by one tank crew. This was a solution to the tactical problem that had stalled the Allied advance for 6 weeks. If every Sherman in Normandy could be equipped with a hedgerow cutting device, the bocage would cease to be an insurmountable obstacle and become merely difficult terrain. But manufacturing and installing these devices for hundreds of tanks presented a logistical challenge that required immediate action. The Allied invasion force included thousands of vehicles. but the specialized ordnance companies that might manufacture such devices were overwhelmed with standard maintenance and repair work. Producing enough hedgerow cutters to equip even a single armored division would take weeks using conventional manufacturing and supply chain procedures. The solution came from the same source as Kulin's original innovation: improvisation, backed by overwhelming material abundance. The beaches of Normandy were covered in German steel obstacles. The Allies controlled those beaches absolutely. The raw material for thousands of hedgerow cutters was sitting unused on sand that had been bought with American blood. And behind those beaches were ordnance companies with cutting torches, welding equipment, and soldiers who could be taught to fabricate Kulin's device in a matter of hours. General Omar Bradley, commanding the First Army, made the decision to mass-produce the hedgerow cutters with a priority that rivaled ammunition resupply. Ordnance units received specifications for the device, dimensions, angles, mounting points. Work crews descended on the beaches with cutting torches and trucks. The Czech hedgehogs and other German obstacles were cut into sections. Fabrication lines were established in depots just inland from the beaches, where crews worked around the clock welding prongs to mounting plates. Tank crews rotated back from the front for installation. The process took hours rather than days. A Sherman would arrive at the depot, often damaged from combat or simply worn from 6 weeks of continuous operation. While mechanics performed standard maintenance, welders attached the hedgerow cutter to the tank's bow. The crew would receive a brief orientation on the device's use. Maintain speed when hitting the hedgerow. Keep the angle low. Don't attempt to climb over and then return to their unit. The scale and speed of this improvised production and installation program was possible only because of the logistical system the Allies had established in Normandy. By mid-July, the beaches that had been scenes of chaos on D-Day had become efficient ports handling thousands of tons of supplies daily. The infrastructure to move materiel from ship to depot to frontline unit was functioning smoothly. Adapting that system to manufacture and install a new piece of equipment was simply a matter of priority and organization. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late July, as preparations intensified for Operation Cobra, the massive offensive designed to finally break out of the Normandy bocage, hundreds of Shermans had been equipped with hedgerow cutters. The devices acquired various names among the troops. Some called them tusks, others called them Rhine teeth, in mocking reference to Rommel's Rhine River defences. The most common name, the one that stuck in official reports and historical memory, was rhinos. Shermans equipped with these cutters became known as rhino tanks. The impact on tactical operations was immediate and profound. Tank platoons that had spent days fighting for individual fields could now advance multiple fields per hour. The rhino tank would approach a hedgerow, accelerate to build momentum, and punch through in seconds. Infantry following the tank would clear the field of any A-field, German defenders, while the tank moved to the next hedgerow. The coordination between armour and infantry, which had been nearly impossible in the early bocage fighting, became feasible again. German defenders found their carefully prepared positions suddenly vulnerable. The tactic of waiting for American tanks to expose themselves climbing hedgerows no longer worked. The rhinos came through at ground level, their belly armour protected, their guns ready to fire the moment they entered the field. Anti-tank guns positioned to cover the traditional gaps in the hedgerows found themselves engaging tanks that came through unexpected breaches. The bocage remained difficult terrain, but it was no longer impassable. The psychological impact matched the tactical advantage. American tank crews, who had spent weeks feeling helpless against a landscape that seemed designed to kill them, suddenly possessed a tool that restored their mobility and offensive capability. The Sherman remained outgunned by German Panthers and Tigers in direct combat, remained thinly armoured by Wehrmacht standards. But in the bocage fighting, where close-range encounters in confined spaces were the norm, the ability to move freely was more valuable than heavier armour or a more powerful gun. Operation Cobra launched on July 25, 1944. The offensive began with a massive aerial bombardment that was supposed to pulverize German defenses south of Saint-Lô, creating a gap through which American armor could pour into the French interior. The bombing was partially successful. It disrupted German communications and destroyed some defensive positions, but it didn't eliminate the Bocage or the Wehrmacht units defending it. What allowed Cobra to succeed where previous offenses had stalled was the combination of concentrated force and the newfound mobility provided by the Rhino tanks. Instead of advancing on a broad front and fighting for every field, American commanders concentrated armor into narrow corridors and punched through, using the hedgerow cutters to maintain momentum. The Shermans that had been stymied in June were now leading the advance, cutting through hedgerows faster than German defenders could reposition to meet them. The breakthrough came within days rather than weeks. By the end of July, American armor had penetrated beyond the Bocage into more open terrain. The Third Army, newly activated under General George Patton, exploited the gap with the kind of rapid armoured advance that Allied planners had envisioned would follow immediately after D-Day. The war of movement that doctrine promised was finally possible, not because of any change in German capabilities or Allied firepower, but because a sergeant from Chicago had figured out how to cut through a fence line. The broader significance of Coulin's innovation extended beyond the immediate tactical advantages it provided. The hedgerow cutter represented a fundamental challenge to the assumptions that had governed Allied planning for the Normandy invasion. The planners in England, working with the best intelligence available, with detailed maps and aerial photographs, with expertise drawn from years of military experience, had failed to anticipate the Bocage problem. They'd seen the terrain but not understood it. They'd prepared for the Atlantic Wall but not for the medieval agricultural landscape beyond it. The solution came not from headquarters staff or engineering specialists, but from a non-commissioned officer with no formal technical training who had simply spent enough time watching tanks die to recognize that a different approach was necessary. This pattern of improvisation in the field, solving problems that staff planning had failed to anticipate, would repeat throughout the war, but rarely with such immediate and significant impact. The question of credit became complicated almost immediately. Coulin's name appeared in some early reports about the hedgerow cutter. But, by the time the device was in widespread use, multiple soldiers and units claimed to have invented or contributed to its development. Captain Jimmy Depew of the 102nd Cavalry Reconnaissance Squadron claimed he developed a similar device independently. Other tankers insisted they'd been experimenting with hedgerow cutters before Coulin's design emerged. The truth, as with many wartime innovations, was probably that multiple people were working on similar ideas simultaneously. The Bocage presented the same problem to every Allied tanker in Normandy. The beaches were covered with the same German steel obstacles. It would have been remarkable if only one soldier had thought to combine these elements. What distinguished Coulin's contribution was not necessarily that he was first, or that his design was uniquely superior, but that his version became the template that was mass-produced and distributed across the First Army at the critical moment before Operation Cobra. The Army, characteristically, tried to formalize credit through official channels. Coulin was awarded the Legion of Merit for his innovation, a significant decoration that recognized his contribution as more than routine duty. General Bradley mentioned the hedgerow cutter in his memoirs, though without dwelling on the details of its invention or crediting specific individuals. Patton, whose Third Army exploited the breakthrough that the Rhino tanks helped create, never mentioned the device in his extensive writings about the campaign. By August of 1944, as Allied armies raced across France toward Paris, the hedgerow cutter was already becoming obsolete. The Bocage was left behind. The Sherman crews who had welded steel prongs to their tanks found themselves fighting in open countryside where the devices were unnecessary weight. Some crews removed the cutters to reduce their vehicle's profile and improve handling. Others kept them attached as insurance or simply because removal required tools and time that could be better spent on other maintenance. The device itself was never standardized in the way that other equipment modifications were. There was no official M-whatever designation for the hedgerow cutter, no technical manual detailing its specifications and installation procedures. It remained what it had begun as an improvised solution to a specific problem. Fabricated in the field from available materials, spreading through informal networks rather than official supply channels. After the war, when military historians analysed the Normandy campaign, the hedgerow cutter received attention proportional to its impact but not to its innovation. The great narratives of D-Day focused on the beaches on Omaha and Utah, on the Rangers at Pointe du Hoc, on the airborne drops behind German lines. The bocage fighting appeared as an unfortunate difficulty that prolonged the campaign, and the hedgerow cutter as a footnote about American ingenuity overcoming unexpected obstacles. But for the soldiers who fought in the Norman hedgerows in June and July of 1944, the difference between a Sherman that could penetrate a hedgerow and one that could not was the difference between tactical mobility and immobility, between offensive capability and defensive vulnerability, between life and death. The junior officers who had watched their tanks burn while attempting to cross earthen embankments understood what Coulin's innovation meant in terms that no strategic analysis could fully capture. Curtis Coulin himself returned to Chicago after the war. He worked as a cab driver again, the same occupation he'd held before being drafted. He gave occasional interviews when historians or journalists tracked him down to ask about the hedgerow cutter. In these interviews, he was characteristically modest, often deflecting credit or insisting that other soldiers had been working on similar ideas. He died in 1993, having lived a deep, full life that included his wartime service but was not defined by it. The hedgerow cutter never achieved the iconic status of other American weapons or innovations from World War II. It couldn't compete with the atomic bomb or radar or the proximity fuse in terms of technological sophistication. It wasn't as visually dramatic as a fighter plane or as strategically significant as a fleet carrier. It was welded steel prongs cut from enemy obstacles, mounted on tanks by soldiers using improvised techniques, solving a problem that shouldn't have existed if planning had been perfect. Yet its very ordinariness makes it significant as a historical object. The hedgerow cutter represented the kind of innovation that industrial democracies could produce, but authoritarian military systems struggled with bottom-up problem-solving, rapid adaptation, the willingness to abandon doctrine when field conditions demanded it, and the logistical capacity to mass-produce an improvised solution across an entire army within weeks. The German army in 1944 was still capable of tactical excellence, still possessed superb equipment in many categories, still fielded soldiers whose training and combat experience often exceeded that of their Allied opponents. But Germany, in the fifth year of total war, could not match the material abundance that allowed the Allies to view beach obstacles as raw materials rather than lost resources. Germany's centralized command structure, whatever its efficiencies, struggled to incorporate innovations from junior ranks with the speed that the American system managed. The bocage fighting and the hedgerow cutter solution also revealed something about the nature of modern warfare that would become increasingly relevant as conflicts evolved beyond World War II. Technological superiority and material abundance, while significant advantages, were not sufficient guarantees of tactical success. Terrain mattered, local conditions mattered. The ability to adapt doctrine and equipment to unexpected circumstances mattered as much as the quality of planning that preceded engagement. The American army that landed at Normandy in June of 1944 was not the same army that broke out of the bocage in late July. The difference wasn't new equipment shipped from the United States or replacement units with better training. The difference was accumulated experience, learned adaptation, and specific innovations like Coulin's hedgerow cutter that addressed problems the planners hadn't anticipated. This pattern of military organizations learning and adapting in the field, of doctrine evolving under the pressure of combat, of individual soldiers generating innovations that altered tactical possibilities, was not unique to the American Army or to World War II. But the bocage fighting provided an unusually clear example of the process, and the hedgerow cutter provided an unusually concrete artifact of it. In the decades after the war, as military historians developed more sophisticated understandings of combat effectiveness and institutional learning, the hedgerow cutter story became a case study in adaptive innovation. Military academies used it as an example of the importance of empowering junior leaders to solve problems without waiting for direction from higher headquarters. Engineering schools analyzed it as an example of appropriate technology, solving a complex problem with simple means matched to the specific context. The physical artifacts, the Rhino tanks themselves, largely disappeared. Most were scrapped after the war or had the cutters removed and the steel recycled. A few examples survived in museums, usually restored tanks from Normandy that retained their hedgerow cutters as period-accurate accessories. These museum pieces, with their crude welded prongs extending from otherwise standard Sherman hulls, offered visitors a tangible connection to the specific problem of the bocage and the term improvised solution that helped overcome it. For the veterans of the Normandy campaign, memories of the hedgerows remained vivid long after other battles blurred together. Men who had fought across Europe, who had experienced the Ardennes in winter and crossed the Rhine in spring, who had seen the liberation of concentration camps and accepted German surrenders, still recalled the claustrophobic terror of the bocage with particular clarity. The hedgerows represented a kind of warfare that armoured doctrine hadn't prepared them for, where visibility was measured in yards and every field was a potential kill zone. The transformation that the hedgerow cutter enabled from immobility to movement, from defensive vulnerability to offensive capability, carried significance beyond its tactical impact. It represented a psychological shift, a restoration of confidence in equipment and doctrine that had been severely tested by 6 weeks of bocage fighting. The knowledge that their tanks could now penetrate obstacles that had previously stopped them cold allowed American tank crews to approach the next phase of the campaign with renewed, aggressive spirit. The timeline of innovation, mass production, and deployment compressed into late July of 1944 illustrated both the flexibility and the industrial capacity of the Allied war effort. From Kulin's first prototype to hundreds of equipped tanks took roughly 3 weeks, a period that in peacetime military procurement would barely be sufficient to schedule the initial planning meetings. This speed was possible because the logistical infrastructure was already in place, because the raw materials were literally lying on the beaches, and because the command structure was willing to prioritize an unproven field innovation over established procedures. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.